Hey guys, so today we're going to discuss maximum subarray problem. In this, we have to uh, find the largest sum of a subarray in the given array. Suppose we are given minus 2, 1, minus 3, and 4, and if we are given this array, the maximum sum would be 6. Why? Because this subarray has the maximum value. Any other subarray will have a value less than this. Okay, the most brute force, the most naive approach we can think of is that we generate all the subarrays and get point A, get point B, and sum all the elements between them, and then check if they are the maximum, if that is the maximum sum, and keep updating the maximum sum variable that we have assigned. Now that would take O of n cube. Another approach is that instead of generating point A and B, we just directly sum up the values in each iteration, and that way we can have a time complexity of O of n square. Even better approach would be to use a sliding window, and that is what we are going to discuss. Alright, initially we can have a sum value which is equal to 0. So what we are going to do is we are going to take a left pointer and a right pointer, and as long as our sum is positive we keep moving the right pointer, and if our sum is negative we move the left pointer and subtract the value that is at the left pointer and move the left pointer ahead. Let's see it in practice. So we'll have our left pointer equal to 0 initially, and our right pointer will also be equal to 0, and we'll begin at let's also get the size first. The size would be nums dot size, and r would go on up till n, and we continue moving r, and our sum would be plus equal to the element at r pointer, and we'll have another loop where our L should be less than n, and we will continue this loop until our sum is less than 0. And what we will do is we will subtract the element at L and move the L left pointer to the next element. Alright, and we need another variable called answer, which will be initially 0, and to answer we can assign the maximum of answer or sum. In the end we'll return the answer. This approach will give us a time complexity of O of n, which is really good, and this should get accepted. Okay, there's something wrong. Nums equals to -1, output should be -1 but -0. Okay, so let's just assign it to int minimum, and answer will also be initially int minimum. Sorry, sum would be 0 and answer would be initially int min. Alright, let's try to submit it now. Okay, it doesn't work. It should have worked. Oh right, we should move the answer above the while loop. Why? So that we can check more subarrays. If we check answer here, if we assign the maximum value here, then we are not testing all subarrays. We are not able to get all values possible with our sliding window. Hence we are doing it above the movement of our left pointer. Before our left pointer moves, we have to sum it up. And let's check if this works. Yes, it works. Alright. However, this approach is really good, but we have another approach. It's called Kidane's algorithm. And this Kidane guy says that whenever the sum of a subarray is less than 0, we discard the current subarray and we start a new subarray and start summing up the values. How? Let's see. Okay, and again we'll have a sum value equal to 0 and we'll start traversing the array. We also need a answer equals to int min, and I would be less than n. Oh, we also need n again. All right, and I goes plus plus, and our sum will be, we will be adding an ith element to our sum, and to our answer we will assign the max of answer and sum. If our sum is less than 0, then we restart the subarray, we restart the sum. All right, and this should give us the answer, right? It works for the basic cases and it gets accepted. Okay, so the time complexity of this algorithm is same as the sliding window algorithm. It's just that this is a famous algorithm and it is I don't think it's intuitive. It might have been in a academic journal or something. I'm not sure, but it's really famous. Most people should know that. Most people in computer science should know that. Thank you.